In this video, we'll be going through an overview of the detailed design process, and we'll be recapping a little bit of what the customer's been doing, but also looking at what the contractors are going to be working on. So up until this point, the customer's actually played a fairly significant role in the project, coming up with the requirements and things like that. And this reminds us how important requirements are, and that if we don't actually work out what the customer wants, if we don't work out their requirements, the project's pretty much doomed to fail because we'll end up designing the wrong thing. And so in our timeline, we're seeing this detailed design phase. We've done our conceptual design, so we know the logical design of what needs to be designed. We've done the preliminary design, so we've got a top level physical design, and now we move to the detailed design. And so in our preliminary design stage, we were translating our logical design in i.e. what we want, to our physical architecture, how we're going to do it. And now we're taking that big picture physical architecture design and creating a blueprint with all the small details, all the subsystem designs, and giving us a complete picture of what we're actually designing. So here's a nice graphic that kind of puts it in context, that we have our conceptual design phase where we've got all these ideas coming forward, and we get our ideas of what we actually want our requirements to be. We then come up with our preliminary design being a top level design showing all the major systems. We then have our detailed design phase where we fill in all the detail, and then of course we need to build the thing. So we've got our construction operations phase where we actually build it, and then once it's built, we can actually use it and put it into operational use. For a house, that will mean people actually living in it and enjoying it. So what are the objectives then? Essentially, we want to finalize the design and finalize the design of all the subsystems as well, pretty much so it's ready that we can actually build it and construct it. So in our previous example, the house that we had there, we're taking the design from a sketch to complete blueprints, ready to basically ready to hand over to the builders to actually build. This includes things like all the floor coverings, the fixtures, the fittings, designing everything, and say, here you go, this is what we want. Go and construct it for us, go and build it for us. So one important thing is that when we join all our components together, we'll create a fully functioning system, that everything will mesh correctly together and everything will actually work together, and we won't have conflicts there between things that won't communicate with each other, or things that won't actually work together for some particular reason. And we'll do some testing related to that. Things like looking at the design stability through our computer simulations and doing some modeling and mathematical modeling or online modeling and working out, will the design actually be stable? Looking at site inspections by council authorities, for example, and getting our final approval from stakeholders saying, yes, this will meet all our needs and requirements and do everything we want. And also the technical things that need to mesh together as well. For example, earlier on in one of the case studies, we saw issues with plumbing where we had different types of metal that were used to seal off some joints, and the galvanic degradation that occurred over time, causing one of them to be eaten away and cause significant failure and cause huge costs as a result of that. So we need to ensure all these things mesh together and that our integrated design actually fits together in an integrated fashion.